ഇത് 6 ഇതാണ് ബർത്തത്. Hello. Good evening, dear students. There was some technical issues about in voice, so therefore we will start once again. The ಇವಾಗ chemistry preparatory Kulburgi region preparatory examination MCQs answers ಅನ್ನ solution ಅನ್ನ discuss ಮಾಡೋಣ. So the ಮೊದಲನೇ question, the Vent of factor. ಮೊದಲನೇ question solution chapter. The topic is Vent of factor. See here, the question is the Vent of factor I for a dilute solution of sucrose is. See here, let me clear. The Vent of factor I for a dilute solution, aqueous solution of sucrose is. See here, sucrose, you already know that the sucrose is a non-electrolyte. Sucrose is a non-electrolyte. So non-electrolytes never undergo dissociation in the solvent or association in the solvent. So therefore they does not undergo any type of abnormality. So because they does not undergo any type of abnormality, so therefore their I value will be neither less than 1 nor more than 1. So therefore they will be equal to 1. Why? Because they never undergo dissociation or association. So therefore there will be only one sucrose only. There is no ions. It will be retained with its molecular formula and molecular mass. So therefore the I value is 1. So next question, second question. If you check the second question is molten NaCl conducts the electricity due to the presence of. See, molten NaCl. This is belonging to the what? Electrochemistry unit. That is second unit. The topic is electrolysis of electrolyte. So here, whenever the electricity is passed inside the NaCl solution, NaCl solution they haven't taken here. They have taken molten NaCl. Molten means melted NaCl, fused NaCl. So whenever the molten NaCl get fused, it will be dissociated into Na plus as well as what? Cl minus. So here, any electrolyte if you conduct, the electrolyte in a molten state, it will be dissociated into cation and anion. There will be free ions we will be getting. So because of this free ions, these free ions undergoes oxidation and as well as reduction and in the respective electrodes, that is cathode and anode. So therefore these are responsible for conducting the electricity. In the molten state we will be getting a free ions to conduct the what? Electricity, because they broken down with their intermolecular that is electrostatic forces of attraction and separated into cation and anion. So any molten electrolyte conducts the electricity because of their what? Free ions. So this is coming from the chapter 2 electrochemistry. Second question from the chapter 2, same electrochemistry topic, same topic, that is also Faraday's law, Faraday's electrolysis or electrolysis topic only. Here they have given in the question 3 Faradays of electricity is going to be passed to the 3 different solution. One is alumina, another is aqueous copper sulfate, and the third one is NaCl. So these are 3 different electrolytes. Alumina contains aluminium with the charge +3. So for 1 mole of deposition of 1 mole of aluminium, we require 3 electrons to add over the aluminium ion. 3 electrons are added to the aluminium ion to deposit 1 mole of aluminium. So 3 Faradays of electricity is required to deposit 1 mole of aluminium. So they have given here 3 Faradays only. In the question also they have given 3 Faradays. So 3 Faraday of generally 3 Faradays of electricity is required to deposit 1 mole of aluminium. So then 3 Faradays of electricity deposits how much? So therefore it will be 3 by 3, that is equivalent to 1 mole only. In the same way, the second solution is copper sulfate. The copper sulfate is having a copper +2 ion. It will gain 2 electrons and deposited as 1 mole of the copper. So 2 Faradays of electricity is required to deposit 1 mole of the copper. Okay, so therefore 3 Faradays of electricity requires how much? So this will be 3 by 2, that is nothing but 1.5 mole. So 1.5 mole of the substance, copper substance is going to be deposited whenever we pass the 3 Faradays of electricity in general. Third one, third one is NaCl. If you take NaCl, Na plus ions will be there. One Na plus ion require the one electron, and after gaining the one electron, it will be going to change it into 1 mole of the sodium. So 1 Faraday of electricity required to deposit 1 mole of the Na. In the same way, they have given 3 Faraday. They passed the 3 Faradays of electricity. So 3 Faradays of electricity deposits how much? That would be how many mole? 3 mole. So the answer is C. Why the answer is C? Because here, here 1 is to, we will be getting 1 is to 1.5 is to 1 mole. Sorry, 3 mole. 1 is to 1.5 is to 3 moles. 1 mole of the aluminum is going to be deposited by passing the 3 Faradays of electricity to the alumina, and 1.5 moles of the copper is going to be deposited whenever the copper sulfate is passed with 3 Faradays of electricity. In the same way, uh, 3 moles of sodium is going to be deposited whenever we pass the 3 Faradays of electricity to the NaCl in a molten state. So this is about the question number 3. The same way, the question number 4, if you check, the radioactive disintegration is an example of. This is belonging to purely the chapter number 3, that is chemical kinetics. So chemical kinetics, the topic is order. See here, radioactivity. Radioactivity is nothing but any unstable, bigger atomic mass containing atom. If it is having an unstable nucleus, it will be broken down into the smaller atomic mass containing atoms, which will be becoming ultimately the stable atom. Nuclear, we call it as nuclear fission reaction. Radioactivity, during that period, it will be emits the what? Radiation. So whatever the radiation is going to be emitted during this process, whatever the radioactive disintegration is going to happen at that period, the speed of this reaction or rate of this reaction is directly proportional to the concentration of the radioactive substance. Whatever the speed of this radioactivity process is there, that will be directly proportional to the concentration of the first power of the concentration of the substance. So here the radioactivity is directly proportional to the first power of the radio concentration of the first power of the radioactive substance. So therefore it is a first order reaction. First power of the concentration of the radioactive substance. So therefore it is a first order reaction. So the answer for the fourth question is B. That is a first order reaction for radioactive disintegration. So all the radioactive disintegration undergoing atoms are always a first order reaction. They exhibit a first order kinetics. So the fifth question is from D and F block elements unit. The question is the color of the what transition metal ions or metal atoms is due to the absorption of some wavelength. So this results in option A DS transition, option B SS transition, option C SD transition, and option D DD transition. So if you have studied, if you observe the D block elements, so the D block elements, maximum D block elements are having a colored ions due to the presence of unpaired electrons in the D orbitals. The presence of unpaired electron in the D orbitals. So these unpaired electrons absorbs the particular wavelength from the sunlight and undergo transition from lower energy level to higher energy level, and they are not available for a longer period of time, and they coming back to the ground state and emits the radiation. While jumping from lower to the higher, they absorb a particular wavelength, and they will be coming back, they will be falling back to the ground state. While that time they emits the what? Radiation or a wavelength or a frequency which is opposite to that of the what? Absorbed or complementary. Sorry, it is it is opposite. If it is frequency is more, the absorption of frequency is more, while emitting the radiation they emits the what, high frequency radiation, while absorption low frequency, during the emission they emits the what, high frequency of radiation. So they generally dd transition is going to be taking place by the what, presence of the d electron. If the d orbital is having a unpaired electron, then only it will be undergoing dd transition, otherwise it will be not undergoing dd transition. So therefore remember, the color of the transition metal ions are due to the dd transition. Dd transition means the d orbitals containing unpaired electron absorbs a particular wavelength and excites to the higher energy level and fall back to the what, ground state, and emits the radiation in the visible region. So whatever the emission of radiation is done in the visible region, that emitted radiation will be responsible for the color of that d block element. So the sixth question, is from the coordination compound. You can check here, they are asking the correct IUPAC name of this complex. See here, the complex is, formula is platinum, 2 ammonia ligands we are having, and 2 chlorido ligands we are having. So if you observe this complex, we will be getting the what, zero charge over this complex. They do not have any counter ion, so therefore it is a neutral complex. So in case of neutral complex, the naming of the ligand, the naming of the complex always starts with the ligand in alphabetical order. If it is heteroleptic complex, it is a heteroleptic complex where we have a two type of ligand. One is amine, another is chlorido. So we will go with the what, its oxidation state. See here, the uh, x is the oxidation number. Let us take x as the oxidation number of platinum, and amine oxidation state is 0 into 2 plus chloride oxidation state is 1 into 2 is equal to 0, because it is a neutral complex. So we will be getting the oxidation state of platinum as +2. So now the naming of the compound always starts with the name of the ligand in a alphabetical order, that too with a small letter. Look at here, two amines are there, so therefore diamine, dichlorido, dichlorido. For neutral complexes, the central metal atom or ion name will be written as it is. So therefore, I am not going to change. It will be written as it is, the platinum, and its oxidation state is +2. So therefore, we have to indicate the oxidation number within a parenthesis by using the word Roman numeral. So what is the name? IUPAC name, diamine dichlorido platinum 2. So see here, diamine dichlorido platinum 2. So therefore the answer is what? B for this question. So this is purely coming from the coordination compound. The topic is naming of the coordination compound according to the IUPAC system. So the name is diamine dichlorido platinum 2. The seventh question. The seventh question is coming from the organic chemistry. You can check. The question is from alcohol, phenols, and ethers. See, I read the question. The ether that undergoes electrophilic substitution reaction. Usually, the electrophilic substitution reactions are done by the what? Aromatic compounds, benzenoid compounds. So here, in the options, we have ethyl methyl ether, anisole, and methoxymethane, and ethoxyethane or diethyl ether. Option A, C, and D do not have any benzene ring where directly the oxygen is bonded. So therefore, the answer is B, because anisole is nothing but it is having a benzene ring which is bonded with the methoxy group. So methoxybenzene. So this methoxybenzene is undergoing electrophilic substitution reaction because this methoxy is a ortho para directing group. It has a lone pair of electron which delocalizes with the pi electron of the benzene ring and creates the negative charge at ortho, and para. So therefore, the electrophiles are going to be attacking in the anisole at ortho, and para. So anisole is the aromatic ether which will be undergoing electrophilic substitution reaction. So it may be asked in any other chapter also. So therefore, you have to always remember that electrophilic substitution reaction is always done by the aromatic compounds such as benzenoid compounds. Next, bromination of the methane in the presence of sunlight. So this is coming from the unit chapter haloalkane and haloarine. See here, the methane, whenever it is brominated in the presence of sunlight, what happens? It undergoes free radical formation due to the homolytic cleavage of the what? Methane. The methane will break here homolytically by the diffusion, by absorbing the energy from the sunlight, and the bromine molecule is also undergoing homolysis. So therefore, the replacement of the H will be done by the what? Br, as in the form of free radical. Because of sunlight, the energy will be very less. So therefore, the CH bond is breaking homolytically, symmetrically, and the hydrogen atom of the methane is going to be substituted by the Br free radical. So therefore, it is a free radical substitution reaction. All the alkanes are undergoing halogenation by absorbing a sunlight. Means you have to make it in your mind fix that they break their CH bond and halogen bond by absorbing a sunlight homolytically. So whenever the old bond is breaks homolytically, we will be getting a free radical, and substitution of hydrogen atom of alkane is done by the what? Halogen. Hence, it is a free radical substitution reaction. So the next question, is ninth question. The ninth question, if you observe, this is coming from the what? Alcohol, phenols, and ethers. So see, they have given propanone. See, propanone is nothing but propane 2-on or acetone reacts with alkyl magnesium bromide. See, I have taken a RMgBr, Grignard reagent. So we will be getting a what? It undergoes a nucleophilic addition reaction where double bond changes to single bond, and the oxygen atom of the propanone undergoes uh, sorry negative charge, and it is going to be added with the Mg plus and Br minus. So we will be getting a nucleophilic addition reaction product. So therefore, it is also called as a adduct. So when we add a water molecule, it will be undergoing hydrolysis and converted in the form of what? Tertiary alcohol. See, you can check here. Always the ketones, whenever it is added with the Grignard reagent, followed by hydrolysis, they will be produces the what? Tertiary alcohol. Always ketones on reacting with the Grignard reagent and followed by hydrolysis gives tertiary alcohol. Any ketone, it may be propanone, butanone, pentanone, hexanone, heptanone, or any ketone. Next, 10th question. The 10th question is a very direct question. That is an example of what? Rosenman reduction reaction. See, it is coming from the chapter aldehyde, ketones, and carboxylic acid. What they have given? Benzyl chloride on reduction with the hydrogen, palladium, supported over barium sulfate, is an example of. It is a one of the methods for the preparation of the what? Aldehyde. See here, benzoyl chloride. This is benzoyl chloride passed with the hydrogen gas in the presence of catalyst palladium supported by this chemical barium sulfate. It undergo reduction, addition of hydrogen, removal of chlorine. So what happens here? We will be getting benzaldehyde or benzenol with HCl, and it is an example of Rosenmund's reduction reaction. Rosenmund reduction reaction. See here, Rosenmund reduction reaction is nothing but it is only applicable for the acid chlorides which has been passed with the hydrogen gas in the presence of catalyst palladium supported over barium sulfate catalyst. They undergo addition of hydrogen or less electropositive element, removal of more electronegative element. That is nothing but reduction, and the name of the reaction is called as which reaction? It will be a what? Rosenmund reduction reaction, and the chemical is benzaldehyde. Option D is the answer. Benzaldehyde. If you check the next question, the question number 11th is which of the following will not undergo HVZ reaction? HVZ reaction is nothing but a Hell-Wohlhard-Zalski reaction. This reaction is applicable for the only the carboxylic acid which are containing alpha hydrogen atom. Remember, the reaction is only for the what? Carboxylic acid which are containing alpha hydrogen atom. Suppose if I have taken a carboxylic acid, see, alpha hydrogen atom means the carboxyl group next carbon is alpha carbon, and alpha carbon bonded hydrogens are alpha hydrogen atom. So such type of the chemicals, whenever they are treated with the halogen in the presence of red phosphorus, they undergo halogenation. Addition of halogen to the alpha carbon, removal of alpha hydrogen atom. So therefore, we will be getting a alpha halo carboxylic acid plus HX. So in these options, we have to check out such type of the carboxylic acid which do not having alpha hydrogen atom, or which is not a carboxylic acid. So we have a four options. Four options. All the four options are containing carboxylic acid. Propanoic acid. If you check the propanoic acid, it will be having CH3CH2OH, COOH. Yes, it is having a alpha carbon. Alpha hydrogen atoms are 2. It will be undergoing HVZ reaction. B, ethanoic acid, CH3COOH. If you check the ethanoic acid, the carboxyl group next carbon is alpha carbon. It will be having 3 alpha hydrogen atom, and yes, it is also undergoing HVZ reaction because of the presence of alpha hydrogen atom. 2-methyl propanoic acid. See, 2-methyl, second carbon is having CH3 group, propanoic acid. Look at the carboxyl group next carbon is alpha carbon. Yes, it is also having a 1 alpha hydrogen atom for halogenation. So therefore, it is also undergoing what? HVZ reaction. So then the answer is a D. Why the answer is a D? Because 2,2 dimethyl propanoic acid. You can check CH3, C, CH3, CH3, COOH. So this is 2,2 dimethyl, second carbon, alpha carbon, do not have any alpha hydrogen atom directly bonded to it. So therefore, there is no substitution of the hydrogen atom of the alpha carbon by the halogen. So therefore, the 11th question is answer is what? D. 2,2 dimethyl propanoic acid does not undergo HVZ reaction. Reason is it do not contain alpha hydrogen atom. Next, question number 12. That is coming from the what? Amines unit. It is a very easy question. Direct question. The nitrogen atom of the amine group is sp3 hybridized. Look at here. Nitrogen atomic number 7, 1s2, 2s2, 2p3. Yes, it utilizes the outermost orbital 1 2s orbital and 3 2p orbital to form sp3 hybrid orbital. So look at here, the amines are having sp3 hybridized nitrogen atom. For formation of a covalent bond, they use 2s as well as 3 2p orbitals, and they undergo sp3 hybridization, and they are having a trigonal pyramidal shape with the sp3 hybridized nitrogen atom. 13th question number is also belong to the what? Amines chapter, where the question is based on the basicity. You can check the question. Which of the following has the highest pKb value? pKb value. See, pKb value is nothing but negative logarithmic to the base 10 of dissociation constant of weak base. So pKb value is inversely proportional to basic strength of the amine. Higher the pKb value, lower is the basic strength. So you have already a knowledge about the basicity of amines and alkyl amines. Alkyl amines are more basic than ammonia. Alkyl amines are more basic than ammonia because the alkyl group is electron donating group. It pushes the electron by the positive inductive effect, and the nitrogen atom lone pair of electrons of the alkyl amines are more easily available for donation, and they behaves as a strong Lewis base than ammonia. So therefore, you have to check the options A, C, and D. All are the alkyl amines. A is a tertiary amine, primary amine, alkyl amine. C is also primary alkyl amine. D is also primary alkyl amine. They all are having lower value of pKb because they are having a greater basic strength than that of the what? Ammonia. Ammonia is a weak base compared to that of the alkyl amine because it do not having any electron donating group, and it do not have capability more quickly to donate the lone pair of electrons. So therefore, its basic strength will be less and the pKb value will be more. Next, the last question is from the biomolecule deficiency of vitamin D. See, deficiency of vitamin D causes the disease that is nothing but C, rickets, soft soft bones or deformation of the bones due to the deficiency of ergocalciferol, that is nothing but what? Vitamin D. Okay, so this is, I hope you all have got the solutions of this paper, and this ends with the what? Solutions of MCQ from the Kalburgi Preparatory Chemistry uh, Preparatory Examination. Okay, so for more classes and for the upcoming KCT and NEET JEE crash course, you can follow us, our channel, and you will be get to know that when we are going to have a online as well as offline KCT classes. Thank you.